In this lesson, we will look at the strengths of acids and bases. We will define weak acids and bases and see how to write an equation representing their behavior and explain the difference between strong and weak acids and strong and weak bases. And we will also list the 6 strong acids. Strong acids are strong electrolytes. As a result, they will completely dissociate in water. For example, HCl will dissociate into H plus and Cl minus ions. There are 6 strong acids: HCl, HBr, HI, HClO4, HNO3, and H2SO4. You should memorize these 6 strong acids. Other acids that are not on this list will be considered weak. Remember that H plus and H3O plus mean the same thing. We generally write H plus, but in solution it is actually present as H3O plus. If we zoom into a solution at the molecular level, we will see that all of the acid molecules, represented here as HA, are completely dissociated. In the solution, we see A- and H3O plus ions, but we do not see any HA molecules. Water molecules are still present. They are just omitted here for clarity. Next, we will look at weak acids. Weak acids are weak electrolytes. Any acid that is not strong, so it's not on the list of 6 strong acids, will be considered weak. One type of weak acid is a carboxylic acid, and these are the organic acids that we saw earlier when we explored functional groups. We often see this written as COOH, and this is our shorthand notation for the carboxylic acid group. We also see the structure here showing the C double bond O and the OH. One example of this is acetic acid, which is found in vinegar. So CH3COOH will partially dissociate into H plus and CH3COO minus ions. The other type of weak acid can be identified by looking at the chemical formula. When you look at the formula and see that it starts with H and it's a compound other than H2O or H2O2, you can assume that this is an acid. Some examples include HNO2, HF, and HCN, which are all examples of weak acids because they are not on the strong acid list. Remember, an acid that is not strong is weak. By knowing the 6 strong acids, we can then determine that other acids are weak. These two images compare a strong and a weak acid at the molecular level. On the left side, we have our strong acid, and we see that we have no HA molecules present. It is all turned into A- and H3O+, and we have complete dissociation. When we look at a weak acid, we see that we have some of the HA molecules remain, but some of them have also dissociated and formed A- and H3O+ ions. So we see that we have partial dissociation in our weak acids. Similar to a strong acid, we have strong bases, and strong bases are also considered strong electrolytes. Compounds that we will consider as strong bases are compounds formed from a group 1 or 2 metal cation and the hydroxide ion. Examples include NaOH, KOH, and MgOH2. When we look at the molecular level, we see that all of the metal hydroxide molecules have completely dissociated. We have M plus and OH minus ions present. As weak acids or weak electrolytes, weak bases are also weak electrolytes. The weak bases we will look at are amine compounds. For example, NH3, which is known as ammonia, will react with water to form NH4 plus and OH minus. NH3, which is also known as ammonia, is a weak base. We can also see that other primary, secondary, and tertiary amines will also form weak bases. While there are other examples of weak bases, these are the primary ones that we will look at. When we compare solutions of strong and weak bases at the molecular level, we see that the strong base has completely dissociated, and so we no longer have MOH, but we have M plus and OH minus ions present. In a weak base, we see the partial dissociation. While we see some of the BH plus and OH minus ions forming, we also see the original base still present.